Hello friends, and welcome to a lecture on operation research. Today we will be studying a problem in dynamic programming. The problem is allocating medical teams to countries. This is Professor Arvind Prasad. To understand this problem, let us take a problem which we have previously solved. The link to the entire solution to this problem is given below, and it's given on the top right too. You can click and have a look at the entire solution. But let's recapitulate on what we did, because it's a good idea to understand how these problems are solved overall before we get into the real problem of allocation of medical teams. In the good old days in Wild Wild West, people traveled from one city to another city in search of gold. Well, it was often a very perilous journey, and if you undertook a journey from any one city to another city to finally arrive at the city where you actually want to search for gold, you actually went into buying insurance premiums so that your trip was insured. So let us say if the fortune seeker travels from A to B, he pays an insurance premium of $2 to the insurance company. Let us say he travels from B to F, he pays an insurance premium of $4. Finally, the fortune seeker wants to go from A to G. Now, the interesting structure of this problem is, from A, he can travel to either B, C or D. And from B, C or D, he can travel to either E, F or G. From E, F and G, he can travel to either H and I, from where he would go to G. So that's a structure of the problem. From A, B, C, D, from B, C, D, either E, F, G, and from either E, F, G, either H, I and J. So this problem can be broken down to stages, where if you're at A, you're at stage 1. If you're in either B, C or D, you're at stage 2. You're in either E, F or G, you're on stage 3. Stage 4 is going to be your H and I, and stage 5 is J. Now the lines, the blue lines, are the stagecoach runs. Now each stage has state. Well, stage 1 has state A, stage 2 has state B, C or D, stage 3 has state E, F or G, stage 4 has stage H, states H and I, and stage 5 has state J. Also, there's a policy decision involved in going from one state to another state. So the policy decisions are nothing but your blue lines, which are the policy decisions. That is, from A you take a policy decision to go to B, from B you take a policy decision to go to G, and from G a policy decision to go to H and J. Well, the entire problem is, how do we take policy decisions, or how do we do stagecoach runs, which gives you the minimum cost in reaching from A to J? Well, for this we create an objective function. In any optimization problem, you create an objective function, and that objective function needs to be minimized based on the inputs you give to the function. So, what's our objective function? Our objective function is Fn S Xn, where S is the state in which you are on any particular stage. That is, N can be 1, 2, 3, 4, 5. And S is the state, that is either A, B, C, D, E, F, G, H, I or J. So S is your state. And Xn is going to be your stagecoach run. That is the stagecoach run you take from going from one state to another state at stage N. So Fn is going to be the total cost for the best overall policy for remaining stages. Now, what does that mean? That is, it is going to be a function which is going to calculate that what is going to be the total cost to go from any stage n to the last stage. S is your state and Xn is your stagecoach run. Now, our policy, our objective function Fn, Sxn is going to be the immediate cost you are going to take from going to one state to another state in a particular stage. So, let's understand that briefly. If you go from A to B, it is going to be the cost involved in going from A to B. So, Cxn is going to be the cost involved from going from A to B. And Fn plus 1 star Xn is going to be the cost, optimized cost in going from B to J. Right? From going from the second stage to the last stage. Going from second stage to the last stage. Well, you can take any decision. You can go from A to C. And then Fn plus 1 would be from stage number 2 to the last stage. Okay. Now let's go to the problem. The problem here is that you have medical teams and they need to be allocated to countries 1, 2 and 3. Now in this table, it shows that if you allocate 0 teams to country 1, 2 or 3, the additional person years of life, that is thousands of additional person years of life, is going to be 0. Now what does this mean exactly? Let us say we have an example. We take an example. We take the example of allocating 3 medical teams to country number 1. Now let us say, supposing we have allocated 3 medical teams to country number 1, what we find? We find that the average life expectancy of one person in that country has gone up by 0.09 years. So 0.09 multiplied by 1000 would make it 90. Similarly, for the entire country, it would just be multiply 90 by the entire country's population and divided by 1000. That would be the average increase in life years for the entire country's population. Now, how do we solve this problem and what is common between this problem and the stagecoach problem? At the outset, if you look at this table, nothing seems to be common. But let's slowly let us understand it. We need to start from country number 1. Allocate teams to country number 1. We obviously cannot allocate all the 5 teams to country number 1 because country number 2 and country number 3 also we need to allocate teams there. So we allocate teams to country number 1. Then we move to country number 2. Allocate teams there. Whatever is left over, we are from country number 1. The rest is allocated to country number 2. And whatever is left over from country number 2 is again allocated to country number 3. Now, how do we make these allocations to all the 3 countries so that there is a total maxima in thousands of person life years increase? Okay, thousands of additional person life years. How do we allocate these 5 teams to all the 3 countries? So now it becomes very obvious that the stage is going to be the countries. That is, stage 1 is country 1, stage 2 is country 2, and stage 3 is country 3. And what is the state? The state is the number of teams. That is, it can be either 0 or it can be 5 or it can be any value between 0 and 5. So let's briefly recap what we spoke in the last slide. Your stage is nothing but country. Your state is nothing but the medical teams allocated to the country. That is, when you go from country number 1 to country number 2, let us say You have 3 teams allocated to country number 1 and 2 teams are left over. So 2 is going to be nothing but the state for stage 2. Now your decision variable is going to be the teams that you are going to allocate to yourself. Please remember, now here the decision variable is the teams that you are allocating to yourself. That is, at stage 2, what is the decision that is being taken? That is allocating number of teams to country number 2. And when you arrive at stage 2, you will take a decision of how many teams will you allocate to country number 2. The objective function here is Fn, Sn, Xn. So Fn is the objective function here. The inputs to this objective function are Sn and Xn, where Sn is nothing but the state. That is, it can be S1, S2, S3, S4, S5 or S0. And Xn is nothing but the teams that you have allocated to a particular country. That is the number of teams that you have allocated to. Let us say you are at country number 2 and you are at stage S2. Then Xn is going to be either 0. If it is 0, it means 0 teams have been allocated to country number 2. If it is 1, then it is 1 team which has been allocated to country number 2. Now this is going to be equal to the person life years at stage n. Supposing you have allocated 1 team, then how much person life years you are going to get out of allocating 1 team, plus the maximum person life years from stage n plus 1. That is Sn minus Xn. That value is going to go here. That is Sn minus Xn is going to go to the value, is going to function n plus 1 star, where this is the optimized value of the same kind of function from stage 2 onwards. Let us say from when we go from country number 2 to country number 3, what is going to be the maximum person life years you are going to have, because the leftover teams have been given to country number 3. Similar can be said for country number 1. If at country number 1 you allocate 3 teams, then in country number 2 you will come to state number 2. Right? So if you have allocated 3 teams, it's going to be P, that is the person life years you are going to get by allocating 3 teams in country number 1, plus Fn, that is F2 star, which is going to be the value of the function or the maxima of the value of the function, maximum value of the function if 2 teams were allocated to country 2 and 3 combined. What would be the maxima if 2 teams were given to country number 2 and 3? Now, in country number 2 and 3, it can happen that you may give 2 to country number 2 and 0 to country number 3 and get a maxima, or it can be you may get a maxima by allocating 0 to country number 2 and 2 to country number 3, or it can happen by giving 1, 1. But who knows? But what is the maxima of that? Right? Plus, of course, allocating country number 3 teams, adding to that. So that's going to be the maximum, or that's going to be the value you're going to have. So when we do this for country number 1, 2, 3, 4, 5, 6 teams for country number 1, we get 6 different values, and out of that the maximum is going to be the maximum of the problem. But here there is a problem. Here, I mean, there's something here. How do we a priori know that what is going to be the value of function Fn plus 1 star? That is leftover teams when we are allocating to country number 2 and 3. What is going to be the maxima? What combination of teams is going to be the maxima? We cannot know a priori. But there's a way or a method in dynamic programming to solve it. We start here from the last country. And the actual solution here, if you have seen the video that I had suggested you, it starts from the penultimate node. That is, the actual solution starts from 1 but the last node. But we have to calculate for the values for the last node first. So the last node is, or the last stage is stage 3. Now there is no stage 4. So F4 star will be 0. So F3 star is going to be the additional person life plus 0. So if 0 teams, or if we reach to state 0 or 0 teams in stage number 3, it's going to be 0 plus 0, that's going to be 0. If we come to state number 1, that is allocation of 1 team to country number 1, it's going to be 50 plus 0. Similarly, allocation of 4 teams, S3 is 4, is going to be 100 plus 0. So X3 star, of course, is going to be 0, 1, 2, 3, 4, depending on what you have allocated. Remember one thing, X3 is allocating what again? Let me tell you, X3 was allocating team to the stage, right? So allocating team to stage, supposing you get 1 team to the 3rd country, you can allocate yourself only 1 because you don't have to allocate it to country number 4. If you get 2 teams to country 3, you have to allocate 2 to country number 3 because there is no country number 4, right? Now, having solved for country number 3, we come to country number 2. So that's going to be node number 2, or it's going to be stage number 2. Now, let us say at stage number 2, you come to 0 state. That is, from country number 1, when you come to country number 2, you have 0 teams left over. So therefore, you can allocate yourself only 0 teams. So the people life, that is the additional people life, is going to be only 0. Now let us say you come to state number 1. That is, you have allocated 4 teams to country number 1. But 1 is left over and it comes to country number 2. Now if you allocate, let us say, 1 team to yourself, then this is 1. If you allocate 1 team to yourself, the person life increase is going to be, or the additional person life increase is going to be 20. Let's have a look here. Let's look at the table. It's 20. If you come with 1 team to country number 2, and if you allocate it to country number 2 itself, the person life increase is going to be 20. But if you don't allocate it to country number 2 and you allocate it to country number 3, then the person life increase is going to be 50. Now let's go back to the table. Fine. If you have allocated yourself 0, so the team goes to country number 3 and the person life increases 50. If you have allocated number 1, so 0 teams go to country number 3. So the person life increase, or the people life increase, is only 20. Similarly, let's come to state number 2 now. Let us say 2 teams have come to stage number 2. Now, if you allocate 0 teams to yourself, so it's going to be 70, which is allocating 2 teams to country number 3. But let us say if you allocate 1 team to yourself, so it's going to be 50 plus 20, 70. But if you allocate both the teams to yourself, it's going to be 45. And have a look here. If you allocate both teams to yourself, it is going to be 45. But if you're allocating yourself 1 team and country number 3 also 1 team, it's going to be 70. I won't go into explaining all the numbers here, but I'll take team number 4 as the last example in explaining this table. So team number 4, so let's say if you get 4 teams to country number 2, that is, 1 team has been allocated to country number 1. So you can allocate yourself 0. In this case, it's going to be 100, which is going to be the sum. Okay. Remember one thing, this 100 is going to be because these 4 teams have now been allocated to country number 3. You can allocate yourself 1. So this means if you have allocated number 1 team to yourself, you have allocated 3 teams to country number 3. Now 3 teams, it's going to be 80, and 1 team is going to be 20, and that's 100. Similarly, all these values have been calculated. Now what is going to be F2 star here? It is going to be the maximum from this rows. That's going to be the F2 star. That is the maximum when you come to any state here. What is going to be the maximum till you go to the end? So from 50 and 20 is going to be 50. From 70, 45 is going to be 70. So you may either go to S1 or S0 or S1. That is, you may allocate either 0 teams or 1 team, okay, to yourself, that is country number 2. Here it is 2, here it is 3, and here it is. Having solved for country number 2 or node number 2, we finally come to node number 1. And remember, in node number 1, there's only going to be 1 state because you have 5 teams to start with. Now, I'm very sure you have understood what is the meaning of a state in any stage. To start with, the only stage number 1 can be is 5. Because to start with, you have 5 teams to allocate. And then the leftover teams go to other countries. So from 5 teams, if you allocate 0 teams to yourself, okay, then the overall value of this function is going to be 160. Now why it is going to be 160? Because you have allocated 5 teams to country number 2 plus 3. Now what is the value here? If you allocate 5 teams to country number 2 and 3, the maximum of the value or the maximum of this is going to be 160. The distribution. Here, remember one thing is the distribution. When 5 teams are coming to country number 2 plus country number 3, allocation ratios or allocation numbers, different allocation numbers. What is going to be the best of it is going to be 160. Now, if you have given yourself 1 team, it means 4 teams have gone down. So, what is going to be the best allocation is going to be 125 people years. Okay. So on and so forth, you calculate if you have given yourself 3 teams, 4 teams, 5 teams. Now, what is the maxima in this? The maxima in this is 170. 170 means you allocate to country number 1, 170. Now, this 170, look up. So, this is going to be, this 170 is going to be here now. So, yes. So, it's going to be 170 here. So, this is 170 here. So, you have allocated yourself 1 team here. Now, if you have allocated yourself 1 team here, the leftover teams are going to be 4 teams. So, go back here. We come to 4. Now, these 4 teams, the maximum is 125. It means in country number 2, you have allocated 3 teams. Well, 1 plus 3 makes it 4. So, the left team, that is 1 team, is allocated to country number 3. And the maximum of all that is 170. So, the allocation is 1 team to country number 1, 3 teams to country number 2, and finally 1 team to country number 3. That's the end of this lecture. And this is the way most of the problems, there are similar problems, allocation of salesmen to territories, similar nature of problems, and allocation of resources to various machines, but they are solved practically the same way. If you have understood how to solve one, you have understood pretty much how to solve the rest of them. Now, it can be only a question of maximization or minimization. That is where you need to take care. So goodbye, friends. Have a great day. Have a great time. And if you like this video, do like and subscribe my channel. And in your comments, if you have any problem in operation research on which you want me to make a video, do tell me. I'll do it. But give me some time for it. And if you like this video, definitely send it over to your friends who might profit from it, and please ask them to subscribe it. Goodbye, friends. Have a great time. Have a great day.